Okay, I've started recording it. So the next thing is after training the SVC model, the next thing is now to predict and evaluate the support vector machine classifier. Now this you said is it this one's? Okay, this maximum iterations shows the number of time that the data set will be seen by the model, while the probability equal to true represents if from what I did there to enable the like probability estimate for stacking classifier, because I want to combine the predictions of the three models, so I have to enable the probability to be true so that it will be quite easy to combine both the support vector machine, the logistic regression, and the random forest model to create a new model itself. So that is what it means. Can I continue? Hello? Okay, so after training the first model, which is the support vector machine model, the next is to evaluate. In evaluating, I have to first of all predict. I have to first of all predict the with the 20% of the predicting variable. Now that is why you're seeing y predict SVM equal to, I'll call the support vector machine model that have been trained already dot predict. So I'm predicting with this model. I'm predicting with this model using the 20% of the predicting variable. Is that clear? Are you with me? All right. Okay. With this X test, remember what I told you about X train and X test. Now X test represents the 20% of the predicting variable. Good. So now, first of all, for me to evaluate the model, I have to predict with the X test, like predict with the model or evaluate the model using the X test, which is the 20% of the predicting variable. Do you understand that, man? So if I click, after doing that, I'll run this. Okay, now this y underscore, okay, now this y underscore pre underscore svm represents like the new prediction, like a new variable that shows the new prediction of the support vector machine model. So now if I create another column, just watch what I'm going to do and say, just watch. If I run it now, just watch. I seen it now. Now what you're seeing here, are you with me? Are you with me? Now what you're seeing here, remember that I have, okay, I have y test. Y test is the 20%, 20% of the predicting variable. What is 20% of the predicting variable? Now, for me to evaluate my model, to determine the accuracy or the performance of the model, I must first of all get a prediction variable, predict, get a prediction variable for the support vector machine model using the x text. The x text is the is the 20% of the predicting variable. So this y pred sum now, is now the predicted, the prediction of the support vector machine model, like that is different from like the y test. Let me do something. Let me show you something. I'm coming. Let me show you something. Now you can see that y test represents zeros and one. Now this y pred sum shows the prediction result of the support vector machine model. So that is what this y pred sum is actually doing. So now after predicting with the support vector machine, the next thing is to now get the classification report. Now in the classification report, what the classification report helps us to do is that the classification report helps us um to see the performance of the model using the y test. Remember, y test is 20% of the target variable and the prediction result of the model. Are you with me? Okay. But do you understand evaluating the support vector machine using the x test? Do you understand this one? This first one, this one. Okay, which one in particular? Which one in particular? Okay, yeah. It's just okay. This widebreed SVM is just a variable name that is a kind of showing the predict that will kind of help to print out exactly, exactly. That will help to print out. Yeah. Now this, yes, yeah, exactly. Yeah. Okay. So in the classification report we have virtually like four stuff that we're kind of evaluating. Or basically the major um 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 parameter, or yeah, let's say parameter or metrics, yes, we call them metrics, that is used to evaluate the performance of a model is accuracy, which is what you are seeing here. Accuracy equal to 88%. Accuracy equal to 88%. So in the classification report, I make use of we make use of the y test, which is the 20% of the target variable, 20% of the target variable, and the y quick SVM, like the prediction of the model, like what the support vector machine is predicting. So we are trying to now compare. Okay, is the like what the support vector machine predicted? Like we're not trying to compare it with the y test, which is the 20% of the um target variable, which will be used for testing. Do you get that now? Okay, so that is for classification report. Now for the rock AUC SVM. Now the rock AUC SVM represent the receiver operation curve. Now, what it does, it helps this receiver operative characteristic curve helps to kind of evaluate if your model is really performing well or not. Now, if the ROC AUC score is below 0.5, it means that the model is not performing well, it's not predicting well. But if the score is above 0.56, 0.9 and above, it means that the model is truly performing well, is truly predicting well. That is what this rock AUC does. Okay, okay. That's what this rock AUC does. Do you understand, sir? Do you understand, ma? Okay. So this print classification ref SVM just print out the results of the classification report, print ROC AUC SVM, print out the results of the AUC report. So after that, you can see the basic um, performance metrics you're actually taking a look at is the accuracy, which is 88%. So the support vector machine, the accuracy of the support vector machine is 88%. Then remember, we have two classes on a dataset. We have 0 and 1. 0 means um 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 like the probability of having um negative result. Then 1, yeah, y1 is positive, like 0 for the target variable. We have yes or no, yes or no. So 0 means no, 1 means yes, 1 means yes. So for this precision score, recall score, f1 score, i will i, I will explain it like in a more detailed way in your chapter 3, in the chapter 3 report. So that one will be thoroughly explained over there. But basically, the performance metrics that we're looking at to evaluate the effectiveness of the model is the accuracy. Now, if you take a look at this 0.93, now this represents the AUC score 0.9. It means that, well, the model is performing well. The model is actually predicting well. Yeah, it's actually predicting well. So this plot rock curve, this one, this 0.93, this one am I right? Yeah, 0.93 is the AUC score. So yes. So now um which one? Okay, these ones are not actually, these ones are not actually they just like a competition of um um these other classification reports, like the average of the whole score that are there. But we don't actually use that to evaluate the performance of the model. So we use accuracy score to evaluate the performance of the model. We use precision, recall, and F1 score. So that is that for that. Then for the AUC score, 0.93 is here. So now I this code you are seeing here, I have to plot the receiver operating characteristic curve. Remember what I said, that the rock, which is receiver operating characteristic curve, helps to tell if your model is performing well or not. Now we have, so this, if I run this cell, it will print this stuff for me. Now remember what I said about matplotlib and lib. So what actually helps to get this diagram here is through the help of matplotlib. You can see plots. So that is, now basically what we are trying to look at here is to show um the area, like the receiver operating characteristic of results, which is 0.93. 0.93. Now this curve you are seeing here showing that okay, the model is actually performing well, but is not actually predicting the whole instances in the data set. So the ROC curve for support vector machine is 0.93. It's actually performing well. Are you with me? Okay, hello. Sorry, I lost my network. Oh. Can you hear me?
Yes, I can.
Okay, what is that for? Okay, for the confusion matrix for SVM. Now let me just explain. Um, it, don't- it, you don't really need to know, kind of maybe um get a full glimpse of what this code is actually saying. Now for the confusion matrix helps to now show like the number of um predicted values that your model was able to predict, like number of instances for the class 0 and class 1. Now for class 0, for class 0.
The network is
Okay, can you hear me now? Can you hear me? Okay, now what confusion matrix does is very simple. Now remember we have two classes here, 0 and 1. 0 and 1. Now the confusion matrix is just like a diagram that displays and shows um, how your model is actually predicting. Now for class 0 we have 484. Then this 32. Now this 484 represent that okay, for class 0 the model is able to predict the total of 484 of class out of the whole instances in class 0. Why 32 means the model was unable to predict 32 instances of the class 0 values. Then for class 1, the model was able to predict 177 of the class 1 and was unable to predict 58. So the confusion matrix is just showing how your model was able to predict your predict using the new data set that is seen. So that is what confusion matrix in simple things. Confusion matrix shows, or is a diagram that shows how your model is predicting. This blue, it means okay, the model was able to predict 484 instances of the new dataset, which is the whitest. White, and it was unable to predict 32 instances. Then for the class 1, 177 the model was able to kind of predict for 177 instances, but 58 instances were like the model couldn't predict well for it. So now this confusion matrix, rock receiver operating characteristics, the classification reports, they actually help to kind of show the performance of the machine learning model. But basically the major metrics is the accuracy score, and the accuracy score um, for support vector machine is 88%. So that is for the support vector machine. Now the same thing we then move to the logistic regression model. So after training the support vector machine and evaluating it and also getting the performance. Now this whole thing that I've done here, I'm going to I'm going to present them, like do a detailed report in your chapter 3 and your chapter 4. Are you following me? Yeah. Okay. So training the logistic regression model, the same thing that was done in the support vector machine. So I had to make sure that the iterations for both support vector and logistic regression are 1000. They are the same. So after initializing the logistic regression model, I then train the model with X train, Y train, just same thing that was done. Then I run the cell. Okay. Like the number of time that the model is going to see the data set. Yeah. So after doing that, you see the logistic regression has been trained already. So if you see something like this, it means that it has been trained. So after training the model, the same step, what I did for um the same step I did for support vector machine, I will still repeat the same thing. Like it's still the same method, the same step. So in machine learning, eh, after training your model, you predict and evaluate with your model. So it's the same, like the same step, but different variable. For the support vector is y print support and SVM. For the logistic regression is y print logist logist. Do you understand what I mean? Okay. So if I just run this, it will print out the accuracy. So you see the accuracy for um logistic regression is still or is 88. Then for the AUC is 94. So um support vector, the rock AUC is 93, but this one is 94, showing that okay, regardless of the fact that the accuracy of the logistic regression is high, now the rock AUC, which shows how well your model is predicting, for logistic regression is 94. It shows that okay, at normal, logistic regression is still like still performs quite little well than the support vector machine. Yeah. So this one is just to create the curve that will present the the rock curve, that is the rock score, which is 0.94. Then after doing that, I create the confusion matrix. Remember what I said about confusion matrix? The confusion matrix explain like the number um of instances that your model is predicting. If your model is predicting um the exact like the number of instances in each of these classes that the model is predicting. For instance, this 480, it means that okay, the confusion matrix for the logistic regression model is able to predict 480 instances of zero well, but it's not seeing 36. It's not predicting well for 36 instances. Then for class 1, 184 was like the model is seeing it well, but 51 instances of class 1 were not predicted well. Yes. So that is that for that one. So now we'll move to training the random forest model. Same steps. Now, random forest model contains like thousands of decision tree model. So it's a combination of like thousands of decision tree model. So after initializing the model, the RF model, I then train it with X train and Y train, which represent 80% of the training of the predicting set, 80% of the target variable. So that is that for the random forest. Then after training the random forest model, I also predict and evaluate the random forest model. Now one thing is in machine learning the steps are like are the same. You follow the same step to achieve the results. So I predict on the test data set, which is this first. I predict first and then evaluate using the classification report, the rock AUC score, and then I print out the classification report on the rock AUC score. Now in printing it out, the accuracy for random forest is 89. Are you seeing that now? So the accuracy for is 89, then the rock AUC score is 94, 0.94. So now random forest is actually predicting well. So after that I now plot the curve. The curve shows then I also plot the confusion matrix. What happens is I'm going to this confusion matrix in your reports you will see a detailed explanation of each of these, like if I yeah what they mean, like this 467 489 49. I'm going to explain them in detail. Once I put the diagram there, I'll explain it below. Okay, this is what this diagram is saying, this is what this diagram is saying. So for now after doing that is developing the assemble model. The assemble model is just like you creating a hybrid model or two or more model, like combining their predictions together to form something new. So now because we want to leverage the strength of random forest classifier, logistic regression, and support vector machine, so we have to kind of combine these classifiers together to leverage on their strengths and their weakness too. So for that I make use of stacking assemble. So in stacking assemble, this code here this code here does the major combination. So if I run this one here, this all this code you're seeing here, yeah, exactly. Yeah. So once I run it, now what is actually happening here is I have my estimators. This random forest model, support vector model, logistic regression model, like the three models that I want to combine together. So I stack them, like I join them together as one, and then try to estimate their prediction. So that is actually what is happening there. Yeah. So after doing that, and I'm train. I'm coming. I'm coming. Again, now this is the prediction to predict for the stack. Now this stack itself, this stack you're seeing here is now the new, like the new name of the model that combines both the random forest, the support vector model, and the logistic regression together. It combines the three together. So if I run this code, I will automatically see. um, okay, I'm coming. Give me some time. Let me resolve something. Yeah. Okay. Starfleet Sky. Brother, thank God for AI. I just stress my life. The model never train. I just dey stress my life, stress my life. Eh? I told you I'm coming. Okay, I'm back.
Okay.
Okay. So how to? Yes, yes, I've resolved it. I've resolved it. I didn't actually include this after combining the model. I didn't train the stack like train the model. That's why I think you will also experience that same issue. Include this code. Thank this I never ever send themselves. Please, I'm coming. Let me send something to someone. Okay, I'm back. Alright, please add this code, this line of code to this one. Let me do that. Isn't it? Okay, after this stacking example, after the stacking example, create another code like another set. Yeah, and just put it here. Wait, should I stop presenting? Maybe you present your screen. Let me see. Okay. Yeah. Is it working now? Okay, okay, okay. I think what happened is let me stop sharing. Present your screen. Let me see. Present your screen. Let me see. You can present your screen. Let me see. Hmm. Yes, now to buy the stuff was 28. 28 plus 14, that is 42. And I paid 30 first. Then this one now 12, making is complete. It's complete, sir. Yes, 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 exactly. Scroll down, scroll down. No, no, there's nothing wrong. It's correct. There's no problem with it. Mm. Yes, like this is just a tree showing how the models were combined together. Yeah. So okay, the final estimator what was used to like estimate the predictions of the three model is the logistic regression, like the logistic regression classifier serve as final estimator to estimate like the combined model. Yeah. A stacking classifier will okay in so I said in stacking classifier we must have a final estimator. Like after combining the three model, we must make use of one of the model as a final estimator to kind of estimate or balance the predictions. So that was why logistic regression was used as the final estimator. So I'll this particular explanation I'll do that in your report too. I'll explain the report. So Okay, I said in stacking classifier, after combining the models, mm, we must make use of one of the model as the final estimator to kind of estimate the predictions of the stacked model. So for the final estimator, logistic regression was used to estimate the predictions of the combined model, like the predictions of the combined model. Yeah. No, not actually the one with the stronger or better prediction. So you can make use of logistic regression any of the model, but it's just done randomly. Like it's not maybe a particular. Yeah, it's just done randomly. Yeah. So you can move scroll down to the next one to print the confusion matrix, the rock curve, and the rest of them. Scroll down. Now run this cell. Run this cell. Yeah, exactly. Yes, yes. Scroll down. Yeah, just scroll down. Oh, move to the other side. Just scroll down where you see. I'm coming. Wait, I'm coming. Yes, that's the end. No, but there's still another one. Move the hand. This one. Now is to save the stack model. Now after training the model, the accuracy of the stack model is 89%. 89% accuracy. Why the um I'm coming. The rock AUC value, which shows how well the model is performing, is 95%. 95%. So yeah, that is the one showing that. Scroll down, you see it. Yeah, 89. Then scroll down to that ROC curve. You see this curve. And yes, I have to just put it in that diagram. Scroll down, you see it. You see this curve on the diagram. Yeah, scroll left like this. Come down. Just scroll down, scroll down. Now you see this curve, 0.95. Yeah, so this was actually the model I saved to use for the prediction. So click on this, run the cell, run the cell. So if you stack model.joblib. So to save the stacked model, I dumped it using joblib. I said to save the stacked model, which was the model that had the highest accuracy. I had to dump it using joblib. Dumping in like what I mean by dumping, like save the model using joblib. So that is what this line of, can you hear me? Yeah, the network is poor. Can you hear me? Okay, just move to this files folder. This files symbol where you imported your data set. Now you see the stack model saved here. So if you come to this part, just come to these three dots. You see download. You can now download the model. So after downloading the model, you can now use it for the prediction. So now let me, okay, okay. So can I move on to the web application itself, or should we schedule it for another day? Another day. Now this after this model you're seeing now, will now be the one to be used for the real-time prediction on the web application. So I'm going yes, so yes. So I'm going to show you how. Okay. Yeah. Exactly. Yes. 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 I'll do that. I'll do that. Yes. Yeah. It do take time because you don't really need to maybe. I actually developed using Django. You don't really need to know how like the whole step goes. I'm just going to show you um the web application itself. So let me share my screen. You can stop presenting. Let me present my screen. I'll explain all these things to you once you have access to the folder, like the the web application itself. I'll explain this thing I did here. So it has started. So I'll just copy this. Once I copy it, I'll create, go to a web page, a web browser, and paste it there. So this is a personalized hypertension prediction system. Username, like you can just give it a username. Let's say John. Enter with the username, then the password, and just with any password you can remember. Then I click login. So once I log in, I'll see something like this. Make it bigger. Okay, okay, can you see it now? So enter variables for hypertension prediction. Gender. First of all, ask which gender. I say okay. Let me say female. Age. Say 35. Do you smoke? No. Please enter the number of cigarettes you smoke daily. 0. Please indicate whether you are currently taking any medication to manage your blood pressure. No. Please indicate whether you have been diagnosed with diabetes. I say no. Please enter your systolic blood pressure. Let me say 120. Please enter your diastolic blood pressure. Let me say 90. Enter your body mass index. Let me say 24.6.8. Just enter your heart rate. Say 89. Enter your blood glucose level. Let me say 130. Predict hypertension. So like I did enter the whole value. There's a mistake. May age 30. You smoke? No. I don't know. 0. I told I have. Enter your total cholesterol level. Let me say 100. 120. If you omit one value, the model will not predict. Let me say 20. Let me say 30. Enter your heartbeat. Let me say 80. Glucose level. Let me say 120. Then the model start predicting. I hope you like how the interface is, right? Hello. Hello. Sorry, I lost my network. It took the light. Yeah. So this is the prediction page. Except prediction result. The system predicts 0. 1 means that you have hypertension. 0 means that. Okay, I'm saying yeah. Sorry. Let me present my screen. I'm sorry. I'm sorry. I see my screen now. Okay, so this is the prediction result page. seated predicted 0. Then 1 means that you have hypertension, 0 means that you do not have hypertension. So this is basically this. So the next thing I actually want to integrate here, the next thing I want to integrate here is the next thing I want to integrate is just like if kind of based on one of the objective of your research, that will kind of give insights to patients on how to um um kind of mitigate or reduce or manage hypertension basically. Yeah, yeah. So on this page, yes, suggestions. So if for instance the model predicts that that the patient has the risk of having hypertension, that's the the web page will automatically open, like it will open on its own, and the person can go through it to see, like read through on how to um um mitigate the risks of having hypertension. Okay, can you hear me? Okay, so I think that is the the only stuff that is remaining for me to integrate here now, of which I'm going to probably do that tonight or tomorrow. Well, so far so good. This is, let me show you the code that actually did this, so that it will not be as if maybe let me show you the code. I'm coming. I actually wrote the code. Yeah, I'm going to do that, but that will be when I'm done adding the last function I just explained to you. That will kind of, yeah. Yes, so once I finish that, probably tonight or tomorrow, I'll send you the folder. Then once I send you the folder, I'll now walk you through on how to. So my major plan is actually to deploy this stuff, like on, like you can have access to it, like maybe on your phone, and maybe have it like your now prediction, like and use it to kind of do like a personal prediction to know if somebody has hypertension or not. So that is basically what I intend doing, and of which I will also I will try my possible best to host it on a web. I'll just send you the link, then you now have access to it on your phone. Once it's going to be like a web, like a web app, you can just have access to it on your phone. Once you enter those details, the model will automatically predict, and you see it, you'll be seeing the results on your phone, not just on your laptop. I think by so doing, you can also send it to some of, like, maybe for evaluation. But basically, if you want to evaluate the system, all actually for evaluation is the performance, the standard performance metrics. We actually use them to evaluate your model. But for this, seeing that is something that can be used by everyone, so you can just, after deploying it on, like, on the web app itself, I'm going to send you the link. Then you can send it to some of your friends, like the people that you want to, like the focused participants. I just want to make use of to just evaluate your system. So that is just the evaluation part of it. You get? Yeah. Yeah. Wait, let me the code. Wait. I'm coming. Let me show you the code. Mm-hmm. I see my screen. I see my screen. Okay, so this the like that model, the saved model, and this is it here. This start model the job lab. So for me to make use of it, I have to load the model here. Load the model. So it's the model that is doing the prediction. So ice. Yeah. So I think we've actually I've done justice to the first one. So I'm going to send you probably by tomorrow. I'll finish up um with the addition of the last thing I want to add there. Then I'll save the folder and then send it to you. And probably I don't know. But what will you be chance tomorrow for a meeting, or which of the days will be chance for me to explain how to run, how access the application on your laptop. Okay. Okay, it's fine. But what time will be convenient for you? Just let me know. Hello? Can you hear me? Yes, I can hear you. Yeah, I can hear you. I can hear you. Yes, I can. Yes, I can. Hello, I can hear you. I can hear you. Yes, I can hear you. Yes, I can hear you. I can hear you. In the morning. By what time? By what time in the morning? Yeah, by what time in the morning? I think it's the network. The net. Okay. Before 12. Before 12. Okay, I should be in my workspace by then. I think to be feasible. It's feasible. Okay. Okay. It's okay. Before 12 is okay. Okay, I'll leave in the morning by, let me say by 10, I should be in my workspace by 10 a.m. in the morning. Okay. Alright. It's okay. It's okay. Yeah. Alright. Okay. Yes, I can hear you. I can hear you. Yeah. You're welcome. You're welcome. You're welcome. Okay. Let me leave the call there. See you nice. Yes. 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 All right now.